Back again for the remaining chapters in Standard 8 Maths. Today we are going to cover solid shapes and mensuration. But before that, let's finish something from the last session. Where is the slideshow? Current slide. All right. So we covered few examples in the last session regarding practical geometry. Now here is asking one problem. Okay, it's saying, is it possible to construct a quadrilateral ROAM in which RO is so and so, OA is so and so, and then it is also giving three angles. So five parameters are given. It is asking, is it possible to construct it? Now before even attempting to construct it, you should observe it and understand that what it is asking. So you see it is asking for three angles, and both are all the three angles are very big angles, like more than 90 degrees. Here one thing you need to understand is that you cannot construct a quadrilateral where the four angles sum is more than 360. So here the three angles are altogether 360, 120, 105, 135 altogether is 360. So that's saying the fourth angle is 0. So it's not a quadrilateral. Like theoretically it's not possible. So we'll say no, we cannot construct it. So see, that's what I've written here. You cannot construct. Now next chapter, here we will just first understand solid shapes. So this is very crucial to understand solid shapes. What are the views of solid shapes? What are solid shapes? We have already covered few shapes like triangle, rectangle, parallelogram, various quadrilaterals and all. But solid shapes means, but those what we covered are two-dimensional shapes. Solid means three-dimensional. So in addition to x and y axis, there is also a z axis. So it is kind of space figures like solid and all. We will cover a few of the common shapes, and we'll understand how the solid shapes are viewed and observed and measured, so that it is going to helpful for us the following section where we are going to study mensuration, measurements and all. So let's start. So what are solid shapes? These are some objects that we can come across in daily life, obviously, because we're talking about three-dimensional objects. These are also called 3D or three-dimensional objects, as they have different views from different positions, as top sides, top view, side view, front view. So few of the examples of solid shapes are sphere, cylinder, cube, cuboid, and cone. So here you see what are the solid shapes. So we are giving one example. This is also from book, textbook NCERT. So it's saying this is a car. Car is a solid because it has it is a three-dimensional figure, where it's the front view is this one, side view is this one, and top view is that one. It is also giving it's the front view, is the side view, and this is the top view. So it's three-dimensional object. So it has different views. Now similarly, there is another example, brick, where the front view is looking like this, side view is looking like this, and top view is looking like this. Okay, we will study most of these figures that we have given example, because we need to understand that, and it is also going to help us in the following chapters. Next one, mapping space around us. So what to map? So why? Because we need to know solid shapes. Then there is also something called a map, where we use maps to understand the location of different destinations. So you want to go somewhere, we can use a map. So it helps us understanding how to reach various destinations around us. So a map depicts the location of a particular object space in relation to other objects of space. That is the basic definition. It's a map where you see here. So per se, there are various things. Library is there, fire station is there, river is there. So it's kind of a geographical region where everything is mapped in a map where all the locations are relatively mapped with a scale and all are pictorially described here. So map depicts a location of a particular object or place in relation to other objects. So these are kind of other objects available here. They use a scale like 1 in million or something like that. So a particular scale is used for all the locations so that you can present them in a particular dimension. Per se, this is kind of 8 by 6 by 8 inch view where you want to depict everything. So these are kind of scaled properly so that when I am viewing it, I should not have a feeling that okay, in the map it is showing little distance, but it is very far. No, so that's why it is scaled properly so that everything fits into in here. It uses symbols to depict different objects or places. As you can see here, it involves a scale which is fixed for a particular map. So the scale used per se, the scale is kind of 1 kilometer equal to 1 centimeter, right? So similarly the area, so 1 kilometer square equal to 1 centimeter square, it could be used like that. You can be anything, 1 kilometer equal to you can say 1 millimeter also. So a particular scale is used to depict it, um, and that got to be fixed throughout the map. It also says that but uses no reference or perspective. So this is not kind of a painting. Map is different than a painting. Painting is just drawn to portray a idea that this is there, that is there, and how they should draw that it look beautiful, but there is no reference or perspective in a map. Map is map, a mapping of a geographic location in a particular dimension, using a proper scale that is constant throughout the map. That's what it is. So it's saying that you will get such examples either to draw a map using a scale. Obviously, you need to use scale and pencil to draw it and draw objects in pencil. But sometimes you will get a map and ask you to color it. These questions are not uncommon, but it just used for your understanding. So you need to refer the book for more idea. But this is the basic understanding. It's saying blue water, red fire station. So it's just saying to color the water is blue, fire station is red, so and so, so that it looks like okay, anybody can distinguish the different objects in the map. Next. Now we are studying three-dimensional or solid shapes. So you should understand what are the faces, what are the edges, what are the vertices. That helps us in mensuration. Faces are made of polygonal regions. So polygonal means having three or more sides. That's called faces. They meet at edges. So the faces meet at edges, which are line segments, and the edges meet at vertices. So this is the current, a basic difference between what is a face, what is a edge, and what is vertices. We can understand with more diagrams and all. So let's see here. So face is called this one. Any side is called one-sided surface is called face. Faces are made of polygonal region. This is a polygonal region, more than three sides. Okay, all the faces meet at edges. So these are called edges. This face meeting here, these are called edges. Or here it is showing this is edge, where this face and the bottom face is meeting here. And these edges, all the edges meet at vertices. Um, so such solids are called polyhedrons. So because the polygonal regions combine together to make a shape, it's called polyhedron. Polyhedron is said to be regular if the faces are made of regular polygons. If it is regular polygon, so it is called a regular polyhedron. If the faces are made of regular polygons, it's called a polyhedron. You will understand more theory around it, because there may be some objectives around it, whether it's a regular polyhedron, whether it is a polyhedron or not. All those things we will discuss in the following slides. And the same number of faces meet at the vertices. So what is the criteria for a regular polyhedron? It is saying that if the faces made of regular polygons and the same number of faces meet at vertices. So this is regular polygon because every vertex has how many faces meeting? 3, right? So that's called regular. It got to be a regular polygon, and the same number of faces meet at the vertex. That's called regular polygon. Read it. I have no vertices. I have no flat faces. Who am I? So this is just a question it is asking. So you can say, okay, no vertices, no flat faces. Then one example could be sphere. I mean, that's the only example I believe. Next. Okay, these are some more figures regarding polyhedrons. What is a polyhedron? What is not a polyhedron? And also, so these are called polyhedrons. Polygonal faces, similar number of faces meeting at vertices is a regular polygonal region. So these are called polyhedrons. These are non-polyhedrons because it doesn't qualify the requirement of polyhedron, which you go to the previous slide. It is saying polyhedron said to be regular. No, so it got to have faces, edges, and vertices, which is not there. So it's not a polyhedron. That's what. So um, there are no edges here. This is a cone. Okay, faces are there but no edges here. Here you sphere clearly understand. So here also there are faces but no edges, and also vertex is not there. So non-polyhedrons. Curved surface. So but solid shapes, there are some terms you need to know. This is called curved surface of a sphere. This is called lateral surface of a cone. This is also for cylinder lateral surface. um, and there are some other terms. What is a convex polyhedron? Concave means it's kind of some depth is there. Convex means some edge is there. So these are called convex polyhedrons. These are not convex polyhedrons. These are not together polyhedrons because the shape is there. It is not following the definition of polyhedron. So it's not. These are kind of very different, not regular polyhedrons, and also saying that these are not convex polyhedrons. Here if you say this polyhedron is regular, its faces are congruent, okay, and vertices are formed by same number of faces, so this is called a regular polyhedron. This example where here this polyhedron is not regular, all the sides are congruent but the vertices are not formed by same number of faces. So that's the reason it is showing that vertices are not formed by, here it is formed by different number of faces, here it is different number of faces. So it's saying that 3 faces meet at A but 4 faces meet at B. So this is which is kind of an example of a non-regular polyhedron. Some other polyhedron examples, these are mostly multiple choice or small questions you will get because theoretical. Prism is another example. Pyramid, we will understand what it is. So this is called prism. What is prism? Base and top are congruent polygons. Base and top are congruent polygons. Okay, lateral faces are parallelograms. So this is kind of, so base can be any kind of regular polygon, and faces got to be parallelogram. So this is a example of a prism. Okay. um, Pyramid, base is a polygon of any number of sides, could be 3 or 4. Lateral faces are triangles with common vertex, so that's called a pyramid. There is also an interesting formula for polyhedrons. For any polyhedron, it is saying that number of faces plus number of vertices minus number of edges equal to 2. If this is there, then only it's a polyhedron. There will be some small questions or multiple choice questions around it. It will ask whether it is a polyhedron, its faces, number of faces given, number of vertices given, number of edges given. You need to see that the parameter values given are conforming to this equation. If it is not there, no, then it's not a polyhedron. Examples: So this chapter is mostly about understanding theoretical concepts and some map drawings. We will use these concepts in next chapter. Okay. So it's just showing, okay, these are the theoretical things that we have covered. You can remember it. It will come short answers or multiple choices, but application of that we are going to study in next chapter. So it's saying that read and practice whatever you are able to find in 10.1, 10.2, 10.3, and practice them. That's how you will understand the theory covered in here. Next, some small examples. Can a polyhedron have 10 faces, 20 edges, and 15 vertices? This is where you need to use Euler's formula. What is that? So it is showing that it is using it. F plus V minus E is not equal to 2, so it's not possible. Simple answer. 2. Is cylinder a polyhedron? Yeah, we saw non-polyhedrons and all. So, um, and it is just showing it. The example is cylinder has three faces and obviously no vertices and two edges in the sense that whatever where the faces are meeting. So it's showing that one is not a polyhedron. Count the number of cubes in the figure. So it's a figure, it is saying count the number of views. So you need to understand this. You can able to understand if you understood what is front view, what is side view, what is top view. So here it looks like 3, but it is 4. One is hidden. So this is more about understanding the theory of solid shapes. And the B figure has 9. You need to count it yourself. Hidden ones also you need to count. And C has 7. Okay. Next one, how many faces, edges, vertices does a pyramid have with the n-side polygon as its base? Okay. What is given is it's a n-side polygon. Polygon of the pyramid has n sides, so that confirms it to how many faces? N plus 2. Okay, because pyramid is so every side of the polygon is conformed to a face, so that is going to be n faces plus top and bottom, so n plus 2 total number of faces. And then vertices going to be 2n, because vertices are nothing but the um, vertex available, where in case of pyramid you will have the bottom n vertices and the top n vertices, which is 2n minus how many edges are there? Edges going to be 3n. So if you look into the pyramid you will understand. So the answer is 2. So hence it is saying right. So it is saying 2 and 3n plus. So if n is the polygon number of edges of the polygon of a pyramid, this is going to be the number of faces, number of vertices, number of edges, and I also demonstrating that it's also following Euler's formula. Okay. So just to confirm your understanding, so these are the pyramids, right? So okay, we will revisit this one in the next chapter. We need to clarify it even further. Thank you.